One topic that comes up a lot when you hear about soil health and soil building is organic farming. But a lot of people find themselves confused about what exactly organic means. So today we're going to look a little at the question of what is organic farming anyway, and how does it relate to soil health, organic matter, and other concepts that we've been studying in this class. The first thing to know about organic is that it does have a very firm, well-defined meaning in farming, a meaning that is regulated by the National Organic Program of the United States Department of Agriculture, or USDA, and which is quite different from its meaning in chemistry. In chemistry, an organic compound refers to any compound that contains carbon. That's what we're talking about when we refer to soil organic matter. Soil organic matter is carbon-based compounds in the soil. But when we talk about organic farming, we are referring to a specific set of agricultural management practices that grew out of a movement of farmers and consumers and is now codified and regulated by the USDA. Any crop sold as organic must be grown on land that is certified organic by a USDA-approved certifier. The USDA's organic rule governs every aspect of farm management, but the fundamental idea behind it is the use of biological solutions to agricultural challenges. One additional thing that's important to understand is that organic certification is given to land, not to the farm business as a whole. So it is possible for a farmer to use non-organic practices and sell conventional crops on some fields, and use only organic practices and sell organic crops on other fields. So we're going to talk here about what happens on organic land. In order to manage land in compliance with the USDA's organic rule, there are several things a farmer has to do. First, in general, they have to use only naturally derived inputs, substances that have been obtained from a naturally occurring biological or mineral source, not synthesized from other compounds. Soil health and soil building is explicitly addressed in the organic standards. Farmers must develop a plan for building and maintaining soil, and must use a crop rotation that meets these goals. The organic rule also includes standards for how animals, if there are livestock on the farm, must be fed, handled, and housed. Farmers have to keep detailed records to document how they're carrying out these practices, and they must allow regular inspections of their farms and practices. There are also procedures governing how organic integrity is maintained throughout the supply chain. For example, tillage equipment that has been used on conventional land has to be cleaned before it's used on organic land to prevent soil that might be contaminated with prohibited chemicals from being brought into the organic field. Organic crops also must be harvested and stored without intermingling with conventional crops. You'll often hear organic products referred to as chemical-free. You might also hear people who are skeptical of organics arguing that that's a meaningless claim, because technically every substance in the universe is a chemical, even water. While it's true that chemical-free isn't a very meaningful term from a chemistry standpoint, it's also true that the organic standards are extremely specific about what substances can be used on organic soils and crops. And most of the commonly used agricultural chemicals are prohibited, including most herbicides, pesticides, and synthetic fertilizers. Under the organic standards, farmers must manage crop and soil health using naturally occurring non-synthetic substances. The rule provides a few extremely specific exemptions for certain synthetic substances in strictly limited situations. And it also includes some exclusions or usage limitations for substances that are naturally derived but are toxic or environmentally damaging. The best source of guidance on the status of particular substances is the Organic Materials Review Institute, which provides regularly updated lists of generic and commercial products permitted for use in organic farming. One theme that you'll hear repeated over and over in organics is feed the soil, not the crop. Soil fertility strategies in organic farming focus on creating rotations that build and protect the long-term health and integrity of the soil. This generally includes some fertilizer inputs, but the overarching goal is to manage the whole system in ways that promote fertile soil. So, if organic farmers aren't using synthetic fertilizers, what are they feeding the soil to make sure that it will have enough nutrients to keep crops healthy and yielding well? For major crop nutrients, particularly nitrogen, the sources are generally biological. Farmers are using legumes in the rotation because, as we've learned, legume plants partner with symbiotic rhizobium bacteria in the soil to fix atmospheric nitrogen into plant-available forms. Farmers may be using legume cover crops, in which case they're incorporating all that nitrogen in the plant biomass directly into the soil. Or they may be growing legume cash crops, like soybeans or field peas, in which case some of the fixed nitrogen is sold off the farm in the form of harvested beans, but some is retained and returned to the soil in the leaves, stalks, and roots that remain behind after harvest. Animal manures are also a common source of organic nitrogen and phosphorus, and so is compost, which is plant material and/or manure that has been partly broken down by microbes and other organisms, as you learned earlier this week. What biologically derived nutrient sources have in common with each other is that, in general, the nutrients provided, particularly when we're talking about nitrogen, are in organic forms in the chemical sense of the word. That is, they're tied up in carbon compounds in crop residues, cover crop biomass, or compost or manure. Relatively little of the nutrient is in the soluble forms that are readily available to plants, but also vulnerable to loss from the soil. So, in effect, these organic nutrient sources serve as reservoirs of nutrients in the soil, releasing them slowly through the action of soil microorganisms. Some nutrients can also be applied in the form of materials mined from rock or natural deposits. But even with mineral sources, the release of nutrients in plant-available forms can be mediated by soil microbes. Avoiding prohibited inputs is a big part of meeting organic requirements. But there are other elements to the organic standards that are equally important and have major implications for soil health in organic systems. Organic farmers can't grow just one or two crops. They must use a diverse rotation, which can mean including a wider diversity of cash crops and/or using cover crops. They have to use mechanical and cultural methods of weed control. An example of a mechanical method might be cultivation, or running tillage implements between the crop rows to dig up weeds growing there, like you see in the picture here. An example of a cultural method might be growing a perennial crop like alfalfa that will be repeatedly harvested by mowing. So any weeds that come up will be mowed off before they can go to seed, gradually depleting the number of weed seeds in the soil. The USDA organic standards also prohibit the use of GMO crop seed or any other products derived from genetic engineering, which refers to the process of directly transferring genetic material from one organism to another, rather than using conventional breeding methods of crossing and selection. Organic farmers face challenges that are distinct from those experienced by conventional growers. Most organic farmers will tell you that the biggest challenge in their systems is weeds. Managing weeds through mechanical or cultural methods is much more complicated and labor-intensive than just spraying them with herbicides. Many organic farmers rely on a lot of what they call steel in the field, or tillage-based weed control. But organic farmers are also acutely aware of the soil health impacts of too much tillage. This is an active area of research in organic agriculture, and many farmers work hard to use cover crops, perennials in the rotation, and other practices that will reduce weed pressure and the need for tillage. But It's true that it's extremely difficult to get entirely away from soil disturbance-based weed control without using herbicides. Fertility is another challenge because organic farmers can't apply synthetic nitrogen like their conventional neighbors. But most organic farmers find that biological nutrient sources can be very effective at providing for the immediate needs of crops and building long-term reserves in the form of soil organic matter. Pest control is another challenge. There are some naturally derived organic approved insecticide sprays, but in general, organic farmers manage pest and disease problems primarily through rotation. So what does an organic crop rotation look like? Well, there are several goals that organic farmers need to meet when they're deciding what sequence of crops to grow. They want to manage fertility and retain nutrients, manage weeds, prevent pest problems, and avoid using any more tillage than necessary. There are several rotation-building strategies that can help meet these goals. Growing a diverse range of crops can reduce the buildup of pest and disease pressure by ensuring that pests and pathogens won't have the same host crops available year after year. Cover crops can help to diversify rotations and also protect soil structure and build organic matter. Legumes in the rotation, as we've discussed, provide soil nitrogen. And perennial crops allow the soil to take a break from tillage and allow the buildup of deep root systems that support active microbial communities and facilitate water infiltration. And, as we've also discussed, can help reduce weed pressure. So diversity, cover cropping, legume crops, and perennials are all features that you're likely to see in an organic crop rotation. Growers who meet all the requirements of the National Organic Program are eligible to be certified organic. In order to be certified organic, farmers must work with a licensed third-party certifying body. All organic certifying organizations are required to hold farms to the same standards. The USDA's organic rule, not the certifier's own rules, governs what practices are and aren't allowed. Farmers must prepare an organic system plan that describes to their certifier all the details of their operation, what crops they are planting, when and where, what inputs they're applying, how livestock are housed and fed, how pests are managed, and how crops are handled after harvest. Non-organic, or what we often call conventional farmers, may also use biological approaches to agricultural challenges. Farmers may be using many organic approved practices, such as planting cover crops or fertilizing with compost. However, if they are using any prohibited practices, any practices or inputs that are not in compliance with the USDA's organic rule, or if they're not working with a licensed certifier, they are not allowed to sell crops under an organic label. Organic agriculture is a rapidly growing sector in Minnesota. In general, the upper Midwest is something of a hotspot for organic farming, and there's a lively and growing organic community here in Minnesota. The Minnesota Department of Agriculture estimates that there are now more than 700 organic farms in the state, covering about 133,000 acres, and as of 2016, with about $106 million in sales. This still makes organic a relatively small piece of the farm landscape and market, but it's one of the hottest growth areas in the food market. The Organic Trade Association estimates that sales of organic products grew 6.4% nationwide in 2017, which is far above the growth rate for the food market as a whole. One of the toughest parts of becoming an organic farmer is going through the transition period. You can't just quit using synthetic chemicals tomorrow and all of a sudden call yourself an organic farmer. As I mentioned before, organic certification applies to a particular area of land. For a piece of land to be eligible for organic status, it must have been managed without any prohibited inputs for at least 3 years. Organic crops sell for a higher price, which offsets the extra costs of managing land organically. Certified organic growers often make much higher net profits per acre than conventional growers. But until the land is certified, the crops can't be sold as organic. So during that 3-year transition period, farmers have given up many of the tools that they were formerly using, like herbicides and insecticides, but they're not yet getting the higher prices for their crops. The USDA has some cost share programs that can help offset the financial hit that farmers can take during the transition and certification process. So if organic agriculture is growing in Minnesota and nationwide, what does that mean for agricultural soils? I mentioned that the organic standards explicitly call for soil building, but that there can also be trade-offs in adopting organic practices, particularly that it can be difficult to avoid relying on tillage for weed control. There have been quite a few studies looking at the differences between soils under organic and conventional management, and how soils change during that organic transition period and beyond. These studies don't always reach the same conclusions, which makes sense. There are many ways to farm conventionally and many ways to farm organically. But some themes emerge when you look at the whole body of science on this topic. First, soils in organic systems generally do show increased soil organic matter, sometimes by quite a lot. Organic soils also tend to have higher microbial biomass and activity. Because there's been a lot of concern about the effects of pesticides and genetically modified varieties in agriculture, there have also been some studies looking at how these practices affect soils, particularly the microbial communities. Some studies have found that certain pesticides and transgenic crop traits, particularly insect-resistant Bt corn, can affect the abundance or activity of particular groups of soil microbes. But in general, these effects tend to be relatively small, and their real-world significance isn't always clear. In the big picture of what makes organically managed soils different from conventional, the really big drivers are the addition of organic material and crop diversity. Cover cropping, applying manure or compost, and planting a diverse rotation of crop species. Those are the things that really produce the increases in soil organic matter and microbial biomass that characterize organic systems. I hope this has given you a clearer idea of the principles and practices of organic farming and how they relate to the soil concepts we've been learning about this semester.